Mr. Clare here for Clare Maths. So we're doing the Advanced Higher Maths 2025 Paper 1 today, which took place on Monday the 12th of May at 9 a.m. Let's just get into it straight away with question 1. Use binomial theorem to expand 1 over x minus 3x to the 4. So we've got a plus b to the n equals the sum of r equals 0 to n of n choose r, a to the n minus r, and b to the r. So in this case, r is 4. So since it says use binomial theorem, I'm going to write the whole thing out to be on the safe side. 4 choose 0. I've got 1 over x to the 4. 4 choose 1. 1 over x cubed. And then I introduce the minus 3x. Then 4 choose 2. 1 over x squared. Then minus 3x squared. 4 choose 3. 1 over x minus 3x cubed. And finally, 4 choose 4. 1 over x disappears to get minus 3x to the 4. So that's our first position. We can just use Pascal's triangle. So Pascal's triangle is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, and so on. But it's this line I need. So it is 1 times 1 over x to the 4. So it's that line we want. So it's 1 times 1 over x to the 4 plus 4, 1 over x cubed, and then it's minus 3x, and then 6, 1 over x squared minus 3x squared, 4, 1 over x minus 3x cubed plus 1 over x. Well, that's gone actually, so no 1 over x minus 3x to the 4. So expanding that out, we've got 1 over x to the 4, and then we've got 4 3s is 12, and then you'll have x cubed on the bottom but an x on the top, so x squared on the bottom. And then you'll have 3 3s is 9 times 6 is 54. And the x's, well, you'll have x squared on the top and the bottom, so they just cancel out. And then you'll have 3 3s is 9 times 3 is 27. And then you've got 27 times 4. Well, 27 becomes 54 becomes 108, and it's a minus 108. X cubed on the top divided by x is x squared. And then finally, 3 3s is 9 times 3 is 27 times 3 is 81. So plus 81x to the 4. And I'm pretty sure that we can just leave it like that. So we're done there. Clare Maths is sponsored by Lecky, the educational publisher for Scotland. They offer viewers of this channel a massive 30% discount. Just use the discount code ClareLearnMaths at leckyscotland.co.uk. The practice question books go all the way from level 3 to advanced higher and include national 3, 4 and 5 apps as well, so you can get any book you need for your studies. These are an excellent resource with questions on every topic and contain work solutions so you can see how the marks are awarded. As you go through the book, the questions get increasingly difficult, so by the time you finish your book, you'll be ready for your exams. Usually £9.99, just use the discount code ClareLearnMaths to get 30% off that. Link down below. SQA Advanced Higher Maths 2025, Paper 1, Question 2. F of x is this, find f dash x. So f dash x, we've got u and v, and it's the quotient rule. So v times u dash, which is 3 2s is 6x squared plus 1, minus u times v dash, which is just 2, all over v squared. Leave the bottom alone because that's already factorized. So expanding and simplifying, I've got 3 6's is 18x squared, 3 1's is 3, 2 times 6 is 12x cubed, 2 times 1 is 2 but 2x, minus 4x cubed, minus 2x, all over 3 plus 2x squared. So 18x squared, 12x cubed minus 4x cubed is 8x cubed, plus 18x squared. And then I've got the 2x's cancel, so just plus 3, all over 3 plus 2x all squared. And we're done there. SQA Advanced Higher Maths 2025, Paper 1, Question 3. Two complex numbers are defined as z is 11 plus 10i, and w is 3 minus 2i. Find z over w. So z over w Well, remember, you can't actually divide complex numbers, so the method is to times by the complex conjugate over itself. So that's just 3 plus 2i over 3 plus 2i. So the top I can expand. 11 times 3 is 33. Then I've got 22i, and I've got 30i, and then I've got 20i squared. And then the bottom, well, you've got 3 times 3 is 9, and then the plus 3 times 2 is 6i, but then you've got minus 6i, so they cancel. So then it's just minus 2 2's is 4i squared. So finding the top, I squared, remember, is minus 1, so you get 33 minus 20, which is 13. 22i plus 30i is 52i. And then the bottom, because I squared is minus 1 times minus 4 is plus 4, 9 plus 4 is 13. Well, you can just do 13 divided by 13 is 1, and 52 divided by 13 is 4, so you get 1 plus 4i, and we're done there. Advanced Higher Maths 2025, Paper 1, Question 4. Matrices A and B are defined as this. Find 3a plus 2b. So a little bit of matrix work. So we've got 3a plus 2b. So times in everything in A by 3 gives me minus 9, 6, 0, and 3, plus 2 2's is 4, and 10, and 2 lambda. Adding them together, just add each individual term. Minus 9 add 4 is minus 5, 6 add 4 is 10, 0 add 10 is 10, and you get 2 lambda plus 3. And that's as done part A. Part B says, find A transpose B. So A transpose, A was minus 3, 2, 0, 1. So we just flip the columns, minus 3, 2, 0, 1 times B. Well, B was 2, 2, 5 lambda. So remember, this works by just times in the row and the column, and that gives us our first term. Then row and column for second term, row and column for third term, row and column for fourth term. So that gives me minus 3 times 2 is minus 6 plus 0. Minus 3 times 2 is minus 6 plus 0 again. 2 2's is 4. 4 plus 5 is 9. And then 2 2's is 4 plus lambda. So we get that. Find an expression for the determinant of A transpose B. So the determinant of a 2 by 2 matrix is just this times this minus that times that. So we've got minus 6, 4 plus lambda, minus 6 times 9. So that gives me minus 24 minus 6 lambda. A minus times a minus is a plus, so plus 54. That gives me 30 minus 6 lambda. And then part C, determine the value of lambda such that A prime B is singular. So singular means that there's no inverse, so that implies that the determinant of A prime B is equal to 0 because you've got no inverse. Inverse doesn't exist. So inverse doesn't exist when the determinant is 0. 6 lambda equals 0. 6 lambda equals 30. Lambda equals 5. And we're done there. SQA Advanced Higher Maths 2025, Paper 1, Question 5. The integral of 1 over 1 plus 4x squared. Well, that looks like 1 over 1 plus x squared, which is like a tan. So I'm going to hopefully get to a tan, and I'm going to let u equal 2x. And the reason for that is if I do 2x all squared, I get 4x squared. So hopefully I'll get 1 plus u squared on the bottom. So let me do that. The u by dx is 2. So 2 dx is du. So that means that dx is a half du. So my integral becomes the integral, I'll just put the half outside, of du over 1 plus, well, 2 2's is 4x squared, u squared. And then sort of example, if I've already said this, that's the inverse tan of u plus c. So that's the inverse tan of putting u back, 2x plus c, and we're done there. SQA Advanced Higher Maths 2025, paper 1, question 6. On a suitable domain, a curve is given by the equation y equals f of x, where f of x is that. Express that in this form. So we've got x squared on the top and x on the bottom, so I can divide because the power on the top is bigger or equal to the one on the bottom. So for part A, x squared plus x plus 5 over x minus 2. X goes into x squared x times. That gives me x squared when I times out minus 2x. Take away. X minus 2x is 3x. And then I've still got the plus 5 hanging about for the ride. Now I go in again. X into 3x is 3. That gives me 3x minus 6. Take away. That gives me 5 minus 6 is 11. So that means that f of x is equal to my quotient, x plus 3, plus my remainder, 11, which is over x minus 2. And we're done there. Part B, state the equations of the vertical and non-vertical asymptotes of the curve. It doesn't ask us to justify it or anything, it just says state. So for part B, vertical, well, that is when the denominator of the new thing, or the original thing, it'll make no difference, x minus 2 is equal to 0. Can't divide by 0. So it's when x equals 0. Sorry, it's when x equals 2. And then non-vertical, not horizontal in this case, it's actually slanted. Because of division, you'll be left with this x plus 3. So that is actually it, y equals x plus 3. If that was just a number here, then it would just be y equals 3, which would give you vertical, but you've got the x plus 3 there, so it's non-vertical. No justification required, it's only worth 1 mark each, so I think we can just stop there. Advanced Higher Maths 2025, paper 1, question 7. So we've got solve the differential equation, dy by dx equals y over 2x minus 1. So I wonder if this is just a variable separate one. Let's just check. If we do dy 2x minus 1, we get y dx. So dy over y equals dx over 2x minus 1. Integrate both sides. Log y then equals the log of 2x minus 1. But then I need to divide by 2x minus 1 differentiated, so that's a half. And I've also got a plus c. So at this point, usually you would manipulate it in some way, but we've actually got initial conditions. Y is 12 and x is 5. So you might as well just sub that in now, and it'll make your life a lot easier if you've got initial conditions. So that means I've got log 12 equals a half log 2 times 5 minus 1 plus c. So log 12 equals a half of log 9. 2 5s is 10 minus 1 is 9 plus c. So that means that I've got log 12 equals log 9 to the half, if you want, plus c. So that's log 12 equals 9 to the half is the square root of 9, which is 3. C is equal to log 12 minus log 3, which is log 12 over 3, which is log 4. So now we can just sub in our initial condition then. Remember, log y is a half log 2x minus 1. So log y is a half log 2x minus 1 plus c, which is log 4. So log y equals log, 2x minus 1 to the power of a half. Adding logs means times, so times log 4 times 4. So now we can exponentiate both sides. So that means that y equals e to the log is just the thing, 4 2x minus 1 to the power of a half, and we're done there. SQA Advanced Higher Maths 2025, paper 1, question 8. These three planes are given by this. Use Gaussian information to find t, the point of intersection. It literally tells you what to do. So we've got 1 minus 1, 4 minus 6, 2, 3, 1, 15, 3, 2 minus 2, and 16. So we want to get zeros in the first two positions where the 2 and 3 are. So I'll do row 2 minus 2 row 1 and row 3 minus 3 row 1. 1 minus 1, 4 minus 6, that's 0. 3 minus 2 is 5. 1 minus 8 is minus 7, and 15 plus 2 sixes is 12 is 27. And then we've got 0, 2, 3 ones is 3 is 5, minus 2, 3 fours is 12. So minus 2 minus 12 is minus 14. And then 16, 3 sixes is 18, 18 and 16 is 34. So then we can just, we want a 0 here, so row 3 minus row 2 to get 1 minus 1, 4 minus 6, 0, 5 minus 7, 27, 0, 0, minus 14 plus 7 is minus 7, and then 34 minus 27 is 7. So finally we've got our thing, minus 7z equals 7, so z is minus 1. 5y minus 7z equals 27. 5y plus 7 is 27. So 5y is 20. So y is 4. And then x minus y plus 4z equals minus 6. X minus 4 plus minus another 4 equals minus 6. X minus 8 is minus 6. So x is 2. So our point of intersection is equal to 2, 4 minus 1. And we're done there. Part B says there's a line and find the point of intersection with a line with plane P, pi 3. So there it is there, and I'll copy down what pi 3 was. And we want the point of intersection between these things. So we can just, for part B, use parametric equations. So for our line, we can just say that equals some parameter, let's say t, and then x equals 3t, the denominator, take away 4, y equals 2t, minus 7 becomes plus 7, and z equals t, minus 4 becomes plus 4, and we can just sub that into our plane. So we've got 3t minus 4, plus 2t plus 7, minus 2t plus 4 equals 16. 9t minus 12 plus 4t plus 14 minus 2t minus 8 equals 16. Simplifying all that, you've got 9 and 4 is 13. 13 minus 2 is 11t. And then you've got minus 12 plus 14 is 2. 2 minus 8 is minus 6. So 11t equals 22. So t equals 2. So we can just sub that back in for x, y, and z. So 3 2s is 6. 6 minus 4 is 2. 2 2s is 4 plus 7. 4 plus 7 is 11. And 2 plus 4 is 6. So our point of intersection is 2, 11, and 6. And we're done there. Part B, C, the line L2 passes through the points T and P, which we just worked out, finding parametric equation of the line. So let's just work this one out. Part C, we have got T being 2, 4, minus 1, and another point P being 2, 11, and 6. So you can imagine that we can have a direction like this between P and T, say, or T and P. Let's just put T and P, and a direction vector in that direction. So looking at the vector T to P, that is P minus T. 2 minus 2 is 0. 11 minus 4 is 7. And 6 minus minus 1 is also 7. So there's our direction vector. Then just use any point you want. So I'll just use point T. If you use point P, you'll get a different answer, but it's not unique. So use T as 2, 4, and minus 1. Then we can just say our equation then is x equals, so we've got 0, 7, 7, so 0 lambda plus 2. For y, we've got 7 lambda plus 4. And for z, we've also got 7 lambda, but then it's minus 1. So in other words, x equals 2, y equals 7 lambda plus 4, and z equals 7 lambda minus 1 is a solution, is an equation of the line. It doesn't say in any particular form, parametric form. Well, that is parametric form, so we're done there. This has been Claire Marston today with the Advanced Higher Maths 2025, Paper 1. Hopefully you found that useful. Get the rest up soon. Take care, stay safe, and goodbye.